Ladies and gentlemen, boys and girls, my name is Mr. Do and science is my business. You are welcome to Mr. Do Science World, and today we're going to look at pulleys. Now let's look at what we mean by pulleys. A pulley is a wheel or is a set of wheels that is used with a rope or a chain to lift a heavy object up or to lower a heavy object down. Let's look at, there are different types of wheels that we can talk about. And these wheels that we can talk about will be determined according to the type of pulleys that we have. So the type of pulleys are a fixed pulley, a movable pulley, and then block and tackle system. These are the three types of pulleys that we have. Let's try and go into calculations by solving some given problems. Okay, so let's look at example number 1. Two boxes are connected by a lightweight cord and are resting on a table. The box have masses of 12.0 kg and 10.0 kg. A horizontal force of 40 Newton is applied by a person to the 10 kg box. We neglect the mass of the strings as it is very light. Question number 1. Find the acceleration of each box. Number 2. Find the tension in the cord. Alright. Now let's solve the problem at hand right now. And we can see that we are having two boxes here and they are being connected by a cord. So we're going to draw free body diagram for each of the boxes, and then we'll find the net force acting on each of the boxes. Okay, so let's begin from there. So I will look at the box number 2, and if I take this to be the box, we can see there is a normal on this side, and we can see that there is weight, and there is a cord here, so this cord is having tension, so we look at the tension there. So therefore we can look at the net force. The net force according to Newton's second law is equals to ma, but remember that net force means the sum of the forces that are acting on the object. And these two forces are equal in magnitude but opposite in direction. So definitely they are not doing any work on the box. What we are going to consider is just the tension. So we can simply just say that the tension is equals to ma. And once we have been able to establish that for box number 2, let's go to box number 1. Okay, for box number 1, we draw the free body diagram and say that the forces that are acting are the normal, the weight, we are going to have here an applied force, and now we can see that there is another part of this cord that is also holding this box. So if the applied force is pulling it forward, that will be pulling it backward. So we will have that tension there in the backward direction. So there is a tension here. Now we need to find the net force. Again, Newton's second law. These two forces are also equal in magnitude but opposite in direction, so they are not working. What is working is this. So let's put the Fa plus T is equals to MA. And now from this point, I have this one equation here, I have another equation here. I can easily just put the values. T is equals to, here there is the mass is 12 kg. So 12 multiplied by A, that will become what? 12A for the tension there. Here we were given the force, the applied force, which is 40. Okay, let me work that out here. So we have 40 there, plus the tension is not known, but we know the mass, which is 10 kg multiplied by the acceleration. So straightforward from here, we are going to have 40 plus T is equals to 10A. And we can easily go back and say that, okay, there is T here, and T here is equals to 12A. So in place of this T, I can put 12A there. So I can say that this is 40 plus 12A is equals to 10A. Now, I will continue and solve the problem on this side. There are like terms that we need to group and solve. So because we can see this is 12A and 10A, they are like terms, so we can just easily, something to consider. Remember here, the force here is going forward, and this is going backward, so they should become what? Negative. So I didn't take that into consideration. So here, this should become what? Negative. So negative T on the side. So this is negative. Alright, so I substitute that there and I have negative here. Alright, so let's move on. So we have now 40 minus 12A equals to 10A. And now I'll transpose this to the other side. So this becomes 40 is equals to 12A plus 10A. And now will be 40 is equals to 22A. And from here, I will divide both sides by 22. So that A is now equals to, we take our calculator, check that out, and we're going to get 1.82 meters per second squared. That is the acceleration. Now we are told to find the tension in the cord. To find the tension in the cord, which is the question number 2, I will straight away say that, okay, T is equals to MA. So let's look at this. If T is equals to MA, and I know this to be 12, I will multiply it by what? The A. And A is given as 1.82. And once we do this and multiply the two together, we're going to get 21.82, and it is tension. The unit must be in what? Newtons. So this is the tension in the cord. And now somebody will ask the question, what about if we decide to use the equation number 2? Well, we can try that and see if we're going to get the same answer. And that was FA minus T is equals to MA. So let's try that and see. If you're looking for the tension, this is given as 40 minus T, and this is given as 10 multiplied by A, which is 1.82. And then straight away we will transpose this to this side and transpose there. So we have 40 minus this multiplied by that. Let's quickly do that and say 10 multiplied by 1.82, and that we are having 18.2 equals to T. Now we have 40 minus the 18.2, and once you do that, we're still going to get the same answer, that our tension is again 21.82 what? Newtons, right? Or 21.8, which is approximately the same value there. If I take this, it's approximately the same value as this. So whichever one we make use of, we should have the same answer. Okay, let's look at example number 2. Two masses are connected by a thin cord which passes over a frictionless pulley. This device is called Atwood machine. Find the acceleration of the 2.5 kg mass and the tension in the cord connecting the two masses. So in this situation, as you can see, we are having two masses. As it is, there is a cord and there is another cord with a pulley in there. Right. Let's check and see. The mass of this is 1.0 kg. The mass of this is given as 2.5 kg. What we are looking for is we want to find the acceleration and the tension in the cord. So let's check it and see. From this point, the first thing you need to ask yourself is, in which direction is the object going to move? Well, when you look at this, you can see this is 1.0 kg and this is 2.5 kg. Simply implies the bigger one, the load is going to move to the direction of the bigger one. So which means that it is this way. Our direction of motion is going to go that way. This goes up and then that also descends down there. So to solve this problem, we need to draw a free body diagram for each of the masses, and then we'll be able to find the net force, and that will help us to find out the tension. So let's see. I have free body diagram for this. This object is not on a table, it is hanging. So if it is hanging, what we can see is the force that is in this rope or the cord, and that is the tension. And we can also see that there is a weight because it has mass. So there is weight. And we can do the same thing for this. And we can also see that if I look at that, also there are two forces that are acting. We also have the tension again, and we have the weight. Now let's try and solve the problem one after the other. 1.0 kg and this is 2.5 kg. Now let's try and find the net force on this and the net force on this. The net force here is just simply these two forces that are there. But where is the object going? It's going in upward direction. So we will consider the force going in the direction of the motion as positive, while the one going opposite the direction as negative. So this is going up, tension is positive, and this is coming down, negative, equals to MA. And now I can do the substitutions and see. So we can see T minus mg is equals to m into what? A. And T minus m is now 1.0 multiplied by 9.8. Another thing you can do is you can decide to ignore this negative sign, and then if you are ignoring the negative sign and you get to this point, we have to consider that value to become negative because it is acting downward. Acceleration will always be negative. But in this case, I've taken care of that by this negative sign here. And this must be equals to 1.0 multiplied by the acceleration. So we'll have T minus 9.8 is equals to A, because 1 multiplied by that will give us the same thing. So automatically my tension to be A plus 9.8. That is for this, the 1 kg object. Let's look at the 2.5 kg. So 2.5 kg. If I look at the 2.5 kg, I can see also there are two forces, but let's see which is positive, which is negative. The object is going down, in this case here, so I will consider the force going down as positive and the force going up as negative. So if you look at this, we can see the weight is going down, the tension is upward. Therefore, this will become F net is equals to MA, and that is FG minus T is equals to MA. And from this point, let's try and do the substitution, because we're going to have mg minus T equals to MA. Mass is 2.5 multiplied by A minus T, 2.5 multiplied by A. Okay, let me clean and get enough space so we can easily see what we are doing. What I have is 2.5 times A, and that is going to give me 2.5A minus T is equals to 2.5 times A, again, is going to give me 2.5A. And from here, what am I going to do? I am going to just transpose, simplify, and solve the problem. Okay, now let's look at the 2 kg, the 2.5 kg. 2.5 kg, we see that there are two forces, one up, one down. So when we look at them, our F net is equals to MA. The free body diagram is like this. And the object is going downward, so I am going to take the force going down as positive and the one going up as negative. I'm deciding to take the direction of motion to be positive. So the direction of motion is this. So therefore I have what? Fg minus T equals to Ma. What is Fg? It is what? Mg minus T is equals to what? Ma. And now we can do the substitution. So it is 2.5 multiplied by 9.8 minus T equals to 2.5 multiplied by A, which is the acceleration. So straightforward from here, I make use of my calculator and say 2.5 multiplied by 9.8, and what I'm having is 24.5 minus T is now 2.5A. Okay, tension is here, tension is there. I am going to substitute the value of the tension here into this equation. Or I can make the tension the subject and then solve the other way around. So I can say this is 24.5 is equals, minus 2.5A equals to T. Now these two, T is this and T is this as well. I can equate the two and solve them together. So let's do that. Okay, so what I have is 24.5 minus 2.5A equal to, T is also here, so A plus 9.8. Now I'll transpose this, collect like term, so I'm going to transpose this to this. This becomes 24.5 minus 9.8 is equals to 2.5a plus a, and automatically here this becomes 3.5a, and this is 24.5 minus 9.8, and that is going to give me 14.7. And I just divide, okay, let me draw it closer. 14.7. I divide this by 3.5, I divide this by 3.5. And then A is now divided by 3.5. So my A is 4.2 meters per second squared. I have gotten my acceleration. So once I've gotten the acceleration, where is the acceleration going? Because acceleration is a vector. I want to know where it is going in this case. It is going where? It is going downward. So I can conclude to say that it is 4.2 meters per second squared, what? Downwards. Because it is going down. Okay, we can find the tension in the cord, and knowing from any of the two equations that we have, we can easily make use of them to find the tension in the cord. I can decide to look at this from the point to say, okay, I'm looking at the one that says T is A plus 9.8. What is the A? It is 4.2 plus what? 9.8. So what is my tension? Automatically this is 13, this is 2, 1, so it becomes what? 14 newtons. So therefore, this is the tension in the cord, which is what? 14 newtons. Alright, let's move on to look at example number 3. Two masses are connected by a thin cord which passes over a frictionless pulley. The coefficient of friction between the block and the table is 0.106. Question 1 says, find the acceleration of the 2.5 kg mass. And question 2, find the tension in the cord connecting the two blocks. Now let's look at the problem and see how we can go about solving the problem. Okay, so from my table, I need to draw a free body diagram for the 2.5 kg and for the 1.0 kg. So we can see that from the 2.5 kg, if I look at it, it is on a table. So there are 4 forces that are acting. And the reason is because now we were given the coefficient of kinetic friction, which means that friction is to be considered. So this is the body, and now we are having the normal. We have the weight. We're going to have that to be the tension because that is a cord. And now we're having a frictional force on this side. That becomes the free body diagram for this 2.5 kg. Let's look at the 1 kg. The 1 kg is just hanging. It's hanging by being held by a rope or a cord. So we can also look at that 1.0 kg and say the free body diagram for that is going to be this. We have tension there, and then we have the weight. These are the two things that we can look out for. Now, first thing we want is to find the acceleration. So I can talk about what? The net force here by stating Newton's second law. And we know that we are considering only the horizontal forces. So I will look at it and say, okay, tension is positive. The frictional force is a force of opposition. It's negative. And this is what? MA. Now make the tension to be the subject. So tension is now this. And now let's look at that for this as well. The 1 kg. That our F net is also going to be equals to MA. And that will mean that the weight minus the tension is equals to MA. And we know the weight is mg minus T equals to MA. So we can make T the subject actually and say that it is, sorry, this is mg. You can say it is what? mg minus MA. And this also becomes the equation for the 1.0 kg. And this is the equation for the 2.5 kg. Okay, friction. On the other side, friction is simply the coefficient of kinetic friction times the normal. And this is on a plane table, a flat table, so the normal is always equals to the weight. We learned that earlier in the first video. Alright, so if you look at that, then we can say that F is now equals to the coefficient of kinetic friction times mg. So therefore, this tension here can simply be mass times acceleration plus the coefficient of kinetic friction times the mass times the field strength or gravity. So we're going to equate the two and solve them together. This is now equal to this, and then I'll substitute the values and solve for the acceleration. Right. So I'll say MA plus coefficient of kinetic friction is equals to mg minus MA. Now, let's solve from this point. The mass here is different from the mass here, so don't try to cancel out. So let's do the substitution. This is 2.5 multiplied by the acceleration plus the coefficient of kinetic friction, according to the question, was given to be 0.106. So this is 0.106 multiplied by the mass, which is 2.5 multiplied by the 9.8. Okay. All these must be equal to, the mass here is 1.0 multiplied by 9.8 multiplied by, minus 1.0 multiplied by the acceleration. So let's multiply all these together, and then we will make use of the calculator to do that. So let's see. We have 2.5 multiplied by A so 0.16 0.106 multiplied by 2.5 multiplied by 9.8. This gives you 2.597 equal to, this is 9.8 minus A. And I will collect like terms again. This can come here and that can go there. So I am going to have, this is 2.5A plus A is now equals to 9.8 minus 2.597. And let's see what we're going to have. This 2 is going to give me 3.58 is equals to, this is 9.8 minus 2.597. And that is going to give us 7.203. And I'm looking for A, so I will divide through by 3.5. So A is now going to be 2.06 meters per second squared. This is the acceleration that we are looking for. So I have found the acceleration. Okay, so let's solve the number 2. And the number 2 wants us to find the tension in the cord. So to find the tension in the cord, I can make use of any of the equation for the tension, and then that will give me the answer that I'm looking for. So I can decide to use this, which is one of the equations for the tension, or the one that says tension is equals to this. Any of these two should give me the same answer. So let's try and see by using the 2 and see if we're going to get the same answer. All right. So I take the first one, and that is tension is equals to mg minus ma, and I have found my acceleration to be 2.06, right, or 2.5 something, right. So let's say I decide to put in the values from here. The mass for this is the mass for 1.0. So that will be 1.0 multiplied by 9.8 minus 1.0 multiplied by the acceleration, which is 2.06. And if I do that straight away, I'm going to have 9.8 on this side, and this side also I have 2.06. And once I subtract these two, I am going to have 7.02 or 7.7, sorry. So 7.7 newtons. Okay. So I have gotten 7.7 newtons on this side. We can use this as well and check to see if we're going to get the same answer. And I believe we should have the same answer. So let's just try that and see by using it. And we will say that it is T, which is this one, the value here. So let's do the substitution straight away and see this is G. Okay, so T is now, M is now 2.5 multiplied by A, which is 9.8, plus the mu was 0.106 multiplied by 2.5, and then we'll multiply that by 9.8. Oh, sorry, this is the acceleration, so let's put the value of acceleration there. The acceleration is 2.06, right? So if you work out this together, we should have 7.7 Newton as well. Okay.